Okay, so the next set of notes is starting chapter 19. Chapter 19:1 is over the square root property and completing the square. So we kind of looked a little bit at that square root property when we were learning about how to factor the perfect squares. So that first concept is going to be a little repetitive. The next concept, we're going to use those ideas to complete the square, which is another way to factor. Okay. So the concepts we're going to look at are solving quadratic equations using the square root property, and then solving quadratic equations by completing the square, and then we're going to look at some literal equations. So concept 1 says solving quadratic equations by using the square root property. So the square root property states for any real number k, if x squared is equal to k, then x is equal to the square root of k and then the negative square root of k. We did this before. All this is saying is that if we had, let's say x squared is equal to 9, we would take the square root of both sides to cancel that x squared, and we would get x is equal to plus or minus the square root of 9. So two answers here, a positive answer and a negative answer. That's all this part is saying here. Okay. So in order to do that, before we can get our answers for our variables have to be by themselves. So for example, on number 1, we're going to have to get p squared by itself. So what are we going to do first? Divide by 4. So I have p squared is equal to 9/4. And I'm going to get rid of that square by doing what to both sides? Taking the square root. Okay. When I do that, I am left with p is equal to plus or minus the square root of 9/4. But remember, we learned the properties of radicals. And that property of radicals says we can do what to that square root in that fraction? Give it to each one. So this is technically p is equal to plus or minus the square root of 9 over the square root of 4. Now that it's given to both the numerator and the denominator, we can answer this because we know the square root of 9 and we know the square root of 4. So that means our answer is going to be p is equal to plus or minus what? 3 over 2. So we could write our answer like this, okay? Or we could write our answer in curly brackets. So negative 3/2, positive 3/2. Okay. These are both two correct ways to write the answer. On the exam, I don't care which way you write it. But I think on the homework, they want you to write the solution set, so this part. So just keep that in mind. They're both correct ways to write the same answer. Okay. Okay, now looking at number 2, we now need to get this x squared by itself. So what are we going to do first? X squared needs to be by itself.
Subtract 75.
Good. So I have 3x is equal to negative 75. Sorry, 3x squared. Now what?
Divide by 3.
Divide both sides by 3, because we need x squared by itself. So I have x squared is equal to negative 25. How do I get rid of that x squared? Take the square root, and then I'm going to have how many answers? 1 or 2? 2. One is positive and one is negative. So square root, so now I have x is equal to plus or minus the square root of negative 25. This square root of negative 25 is going to give us what type of answer? Imaginary. Remember, square root of a negative number is imaginary. So we know the square root of 25, which is 5, and that negative square root is going to give us 5i. So that means our answer is x is equal to plus or minus 5i.
So with a problem like this, do you really only have the square root of negative 25 as undefined if, like, in the class we're just not dealing with imaginary numbers yet, basically?
Yes.
Okay.
So prior to us learning about imaginary numbers, I told you the answer was undefined. But now that you've learned about imaginary numbers, anytime you see a square root of a negative number, you're going to have that I in your answer because we've already talked about it. Okay. So yeah, definitely keep that in mind for the final, because the final is going to be over everything we learned. So that means since we've already learned about imaginary numbers, even if it was a concept we learned in the very beginning, your answer has to include that imaginary number. Just remember that math builds upon each other. Okay. And then another way we could write this is negative 5i in those curly brackets. 2 ways we could write the same answer. Okay. Now looking at this last problem for this concept, we have w plus 3 squared. So that entire thing is being squared is equal to 20. So since that whole thing is being squared, are we able to just get the variable by itself this time? Yes or no?
No.
No, we're not able to because that whole thing is being squared. But we know that we can get rid of a square by doing what to both sides? Square root. So I have w plus 3 squared equals 20. I'm going to take the square root of both sides. That's going to cancel out my square, and I am left with w plus 3 is equal to plus or minus the square root of 20. Because remember, after I take the square root, I always have 2 possible answers. 2 possible answers, a positive or a negative. Now I can get w by itself by doing what? Subtracting 3. So I have w is equal to negative 3 plus or minus the square root of 20. Notice how I put that minus 3 in the front? So I'm not to confuse it with the radical in the back. Okay? This right here could be left as your answer. You do not need to take the square root of 20, turn it into a decimal, give me those answers. If you do that, it's still correct. I just don't need you to do that. So you could write it like this, or you could write it as your solution set, negative 3 plus the square root of 20, negative 3 minus the square root of 20. Any questions about these 3 examples? So the important concept here is if you take the square root of both sides, you're going to have 2 possible answers, a plus or a minus, a positive or a negative. So that's concept 1. Concept 2 is solving quadratic equations by completing the square. So the definition of completing the square is a process to create a perfect square trinomial. So it's the process of creating a perfect square trinomial. Because we know how to factor perfect squares. So if we could turn our problem into a perfect square, then it's easier for us to factor. So typically you have something that looks like this. X squared plus bx plus n. That n value has a formula of 1/2 b squared. So when completing the square, we always take that middle term, that b value, we divide it by 2, so multiply it by that 1/2 and square it, and that becomes our new c value. When we do that, we create an equation that has perfect squares. Okay? Perfect square as in, so we learned about 2 different perfect squares. So remember we had x squared, like say minus 9. That was x plus 3, x minus 3. These type of perfect squares are going to look like the example x squared plus 12x plus 36, which is going to give us x plus 6 squared. So when we're talking about turning it into a perfect squared trinomial, we are talking about this second part, where both of the factors are going to be exactly the same. Okay? So the only difference between the first one and the second one is the second one has a b value. So looking at number 4, it wants us to just find this n value. So this n value here, that makes it a perfect square. So in order to find that n value, remember we had the formula, n is equal to 1/2 b squared. In this case, what's our b value? Looking at number 4, what's our b value? 12. So I'm going to do 1/2 times 12 squared. What's half of 12? 6. And 6 squared is 36. So that means my equation is now x squared plus 12x plus 36. In order to factor that, I take whatever number that I found here, that number after I did that 1/2 b, and that is going to become my factor of x plus 6 squared. If I get a negative number in there, it's going to be x minus that number squared. That's where those numbers come from. But remember, in these examples, the only thing it's asking us to find is this n value. Okay. So again, on number 5, it's telling us to find the n value. So I write my formula, 1/2 b squared. And in this case, what's my b value? Yes, we always take the sign in front, so negative 26. So I'm going to have 1/2 times negative 26 squared. What's half of negative 26? Negative 13. So I have negative 13 squared, which is what number? Go ahead and put it in your calculator. 169. Which means I have the equation x squared minus 26x plus 169. So I found my n value. Once I find that n value, this tells me that I can factor this as x. What number would go there? minus 13 squared. So remember, it's whatever this number goes here. If this question was to pop up on the test, it will ask you specifically this: make it a perfect square. Use the completing the square formula to make this a perfect square. It's just not going to give you something and say solve. It's going to give you those direct instructions. Okay, go ahead and try number 6. Number 6 says find the n value such that the polynomial x squared plus 11x plus n makes it a perfect square. So follow exactly what we did in the problem above. Find your n value. Once you find that n value, go ahead and write that as a factor. Your n value is going to be a fraction. What'd you guys get for the n value? What'd you get for the n value? Anybody get anything?
Can you get decimal?
Yes, but I want it a fraction. I want it as a fraction.
Can it be 30 and a quarter?
Not 30, but the 4 is correct on the bottom. 121 over 4. So if we plug in our b value, which is 11, we get 1/2 times 11 squared. Well, we can't take half of 11, right? Because that would give us a decimal. So I'll just keep it as a fraction, and that fraction becomes 11/2. If I square it, I remember my properties of exponents, and I can square the top and the bottom separately. So this becomes 11 squared over 2 squared, which is 121 over 4. Okay. Which means I have the equation x squared plus 11x plus 121 over 4, which is going to give us x plus 11 over 2 squared. Got to remember those properties of exponents and those properties of radicals. Okay, for number 7, we have n is equal to 1/2 b squared. In this case, what is our b value? -4 over 7. So I have 1/2 times -4 over 7 squared. When I multiply two fractions together, I multiply the tops and then the bottom. So what do I get inside of my parentheses?
16 over 49. Oh, no. Oh, apologies.
Just looking at inside the parentheses, what's 1/2 times -4/7?
-4/14.
Yes. So -4/14 squared. And because the properties of squares, I can give it to each one. So this becomes -4 squared and 14 squared, which is 16/196. Okay. So that means I have the equation x squared minus 4/7x minus 4/14, minus 16, plus 16/196 is equal to the factor x minus 4/14 squared. So this number goes here. So in these examples, 4 through 7, we were just learning how to complete the square. So they didn't give us equations, they gave us expressions and told us to find n. So now we're going to use this concept to actually solve equations. Okay. Any questions before we move on, before we start solving the equations? Okay. So when solving the equations, they give us some steps to follow. So step 1, it says divide both sides by a to make the coefficient 1. So all this is saying is find the GCF. Okay. If there's a GCF to take out, we need to take out that GCF. Step 2 says isolate the variable terms on one side. Okay, so isolate the variable. Step 3 is completing the square. So what we were doing above was completing the square. Okay. Once we complete the square, then we use the square root property and solve for x. Okay. This right here just gives us the steps of completing the square again, but we just did those above, so those should be fresh in your head. So these type of equations is something that you would typically see. You would see an equation like this, and you would try to factor this like normal, right? So if we tried to factor this like normal, we would have our a times c, which is 13, and our b value, which is -6. Are there any numbers that multiply to 13 but add to -6? No, so this would not be factorable using that AC method. And if we can't use the AC method, that means we can't also use what method? Factor by factor by grouping. So if we can't use either of those methods, that is what's telling us to use completing the square. So we can't use these methods, so this implies try completing the square. So again, this is just another way to factor. If no other ways work, we use completing the square. Remember what always works though? You guys remember what always works? If factoring sometimes works, what always works? Using what formula? The quadratic formula. Quadratic formula always works. So keeping that all in mind, we are now learning that completing the square method to factor. So in order to do this, our first step is to make sure we only have our A and B value by itself. So that means we want to move the C value over to the other side. So what are we moving to the other side? Good. So I have x squared minus 6x. I'm going to leave a blank space here and put equals negative 13. That blank space is representing our n value. Okay. So we're going to solve that n value in order to complete the square on the left side. So remember, n is equal to 1/2 times b squared. In this case, b is what number? -6. So I have 1/2 times -6 squared. What's half of -6? -3, and -3 squared is 9, yes. So that means 9 is my new n value. Okay, so I am going to rewrite this as x squared minus 6x plus 9 is equal to -13 plus 9. Why did I add that 9 to both sides? To make it equal. Because I don't want to change the problem. I'm just manipulating the problem. So think of it, whatever I'm doing to one side, I have to do to the other. So I gave one side a plus 9. In order to keep it balanced, I gave the other side that plus 9. However, now this side is a complete square, and we could write that as what?
X minus 3 squared.
Minus 3 squared, good. We use whatever we found in this parenthesis to go here. And then simplifying the other side, -13 plus 9 is -4. Okay. Notice how this now looks like the square root property that we just did prior. So we have x minus 3 squared equals -4. So what am I going to do to both sides to get rid of that square? Square root. So I have x minus 3 is equal to plus or minus the square root of -4. What is the square root of -4? 2i. Remember that negative just turns to an I, so it's 2i. So I have x minus 3 is equal to plus or minus 2i. And I still need to solve for x, so what am I going to do to that minus 3? Add it. So I have x is equal to 3 plus or minus 2i. That's my answer. Remember, I can write this as two answers, 3 plus 2i or 3 minus 2i. Yes?
I think I missed something. What happened to the other 9? The green one?
Yes, this one right here.
The green one.
This one?
Yeah.
Oh, so this equation came from us completing the square.
Yeah.
Once we complete the square, we're able to turn that trinomial into this factor. So it just goes away.
Oh, 9 just goes away?
Because that's what we were doing if we look back up here. That's what we were doing here. We found our n value, which in this case was that -13. I rewrote my whole equation, because remember we got n is equal to 169.
Yeah.
And this equation can be factored into this.
Okay.
So it's just acknowledging that this is now a perfect square, which can be factored into this.
Okay. All right. Thank you.
And that's all that's happening here. This is a perfect square that can be factored into this. Okay, so any questions on 8? Okay. Number 9. Notice that we already have our A and our B value isolated. Okay, so that means we can skip the first step of moving the C value. That's already done for us. What's our next step? We need to find what? Not the GCF. Well, okay, yes. We could find the GCF, and that would help simplify our problem. So yes, GCF of the left side is what? 2m. So we have 2m and then m plus 10. Well, actually, instead of finding the GCF, because we want our variables to all be on the same side, let's try instead just to make the A value, so the number in front of that m squared, 1. So in order to make this value 1, what would I take out instead of the 2m? Just the 2. Because remember in our first step it said to make that A value 1. So if I take out a 2, I'm left with m squared plus 5m is equal to 3. Which means I can do what with that 2 in order to get our A and B value by itself? Divide by 2. So I have m squared plus 5m is equal to 3/2. Okay. Now I'm going to find my n value. Okay. So remember my n is 1/2 my B value squared. What's my B value? 5. So I have 1/2 times 5 squared, which is 5/2 squared, which is 25/4, because I give it to each one. So that means I'm rewriting this side as m squared plus 5m plus 25/4 is equal to 3/2 plus 25/4. I have to give it to both sides. That left side is now a perfect square, so how is that factor going to look like?
M plus 5/2 squared.
Correct. M plus 5/2 squared, so we turn that trinomial into a factor. And then on the other side, we're going to have to combine like terms. So what would be the common denominator between 2 and 4? 4. So that means I'm going to multiply the first equation by what? 2, top and bottom. So I get 6/4 plus 25/4, which is what? 31/4. Now I need to take the square root of both sides to get rid of that square. And I'm going to go ahead and do that over here. So I take the square root of m plus 5/2 squared, and then the square root of 31/4. So I get m plus 5/2 is equal to plus or minus the square root of 31/4. Remember, don't worry about simplifying that square root unless it is a perfect square. Okay, so that numerator, can we simplify the square root of 31?
No.
But what about the denominator? Can we simplify the square root of 4? So I have the square root of 31/2. And then my last step to get m by itself is to do what? Good, so I have m is equal to negative 5/2 plus or minus the square root of 31/2. That's my answer. Okay. And then ideally, I would prefer if you left it like this. If you want to change it to a decimal, I mean, you can. I'm not going to mark it wrong, but this is just the simplest way. And then last example for this concept, we have 2x times 2x minus 10 is equal to negative 30 plus 6x. So remember, we want our x squared value and our x value to be on the same side. So in order to find our x squared value, what are we going to do with that 2x? Distribute. So 2x times 2x is 4x squared. 2x times negative 10, negative 20x is equal to negative 30 plus 6x. That 6x also needs to be moved over. We want all the x's, all the variables on one side. So I have 4x squared minus 26x is equal to negative 30. I want my a value to be 1. So what am I taking out of the left side? 4. So I'm left with x squared minus what? It doesn't simplify yet. So 26 over 4 can just simplify to 13 over 2x. 26 over 4, they're both divisible by 2. That's how I simplified it. Okay, equals negative 30. What's my next step? Divide both sides by 4, so I get x squared minus 13 over 2x is equal to negative 30/4, which I can simplify to what? Yeah, negative 15 over 2. Okay. Now that I have all my x's to one side, I have my a value, I have my b value. Now I need to find what value? N. So remember, n is equal to 1/2 b squared. What is my b value? Negative 13 over 2. So 1/2 times negative 13 over 2 squared. 1/2 times negative 13 over 2 is negative 13/4. And if I square both the top and bottom, I get what number? It's going to be a fraction. 169 over 16. So I am going to be adding that number to both sides of my equation. So x squared minus 13 over 2x plus 169 over 16 is equal to negative 15 over 2 plus 169 over 16. I just added that number that we found for n to both sides. Once I do that, this tells me that this left side can be factored into what? X minus 13 over 4 squared is equal to, and then I need to get common denominators for that right side. So what would be the common denominator? 16. So I'd have to multiply the first fraction by what? 8. So I am left with negative what? 120? Negative 120 over 16 plus 169 over 16. which simplifies to 49 over 16. So I have x minus 13 over 4 squared equals 49 over 16. What do I need to do to both sides now?
Square root.
Take the square root. So I have x minus 13 over 4 is equal to plus or minus the square root of 49 over 16. Is 49 and 16 perfect squares? So what's the square root of 49 and 16? 7 over 4. So this becomes x minus 13 over 4 is equal to plus or minus 7 over 4. And then what's my last step? Good. Add over the 13/4. So this becomes x is equal to 13/4 plus or minus 7/4. So you could leave it like this, but since there are two fractions with a common denominator already, we could write our two answers out as x is equal to 13/4 plus 7/4, which is 20/4, which is 5, and 30 minus 7, which is 6/4, which is 3/2. So if you were to simplify this and do your two separate answers, that would be correct. Or if you were to leave it as just this one answer with the plus and minus, that is also correct. It just depends on what you want to do. Okay. Any questions on concept 2? Most likely you're going to have one of these problems on the final versus the problem before where it's just telling you to find n. So to actually find the answer versus just finding n. And I'll try to make it where it's not so many fractions. Like these examples had a lot of fractions. Then the last concept here is literal equations. We talked a little bit about literal equations a couple units ago. Just remember that literal equations are equations with multiple variables, and you're being asked to solve for one of them. So for example, if you had the equation E is equal to mc squared, and they would ask you to solve for m, or ask you to solve for c. So it's just manipulating an equation. For this example, it says in the following equation, d is equal to 4.9 t squared. Let d be the distance in meters that an object falls, and t be the seconds such that t is greater than or equal to 0. So t is seconds such that t is greater than or equal to 0. Why did they have to add that here? Why did they add that t is greater than or equal to 0? Because time can't be negative. Good. So for part A, it says solve for t. It says do not rationalize the denominator. So that means if we end up with a square root in the denominator, we leave it there. So solve for t. So we have d is equal to 4.9 t squared. If we want to get t by itself, what's our first step? Divide by 4.9. And now we have t squared is equal to d divided by 4.9. What's our last step to get t by itself? Square root. And when we take the square root, how many possible answers do we have? 2. So this is t is equal to plus or minus the square root of d over 4.9. And we would just leave it as is. That's our answer. Okay. The reason it had us solve for t is because in part B, it says how much time would it take for an object to fall 500 meters? So where are we plugging in this 500 meters? For what variable? D. So I have T is equal to plus or minus the square root of 500 divided by 4.9. If we type that into our calculator, 500 divided by 4.9, and then take the square root of that number, you're going to get that T is equal to plus or minus approximately 10.1. And that's typing that all into your calculator. 500 divided by 4.9, and then that answer, you take the square root. So that means we have two possible answers. We have when T is equal to what?
10.1.
10.1, and then when T is equal to negative 10.1. But can we have negative time? No, so that means our only possible answer is 10.1, and our time is in what units? Seconds. So it's going to take 10.1 seconds. So for these type of problems, as long as you're setting up your equation, you could plug the rest in your calculator, and I don't need to see that math.